let's move to next part. So now I will be showing how to add image in Jupyter Notebook and how to solve that question. So I'll be taking the formula of principal stress, maximum and minimum principal stress, and shear stress. And with the help of that formula, we'll be writing the Python code and getting the answer for that formula. So for this, you have to first mark down the cell, and here you have to paste the link of image. So copy any image if it is downloaded, or you can use markdown help exclamation mark in square bracket image, and in the parentheses you can put the link, or you just paste the link over here. Okay, and shift enter, execute this. So here you can see the calculation for principal stress formula. So this will give us maximum and minimum principal stress and the shear stress, maximum shear stress. So with the help of plus sign, you'll be getting sigma max. With the help of minus sign, you'll be getting sigma minimum. So let us write down the Python code to take the input from the user. So take the input from the user, and then find the value of principal stress. So I will be starting with one variable Sx, stress in x direction. I will be taking float input from the user. Float input from the user. Ask the user to enter the value of stress in x direction. Enter the stress in x direction. Okay, so this will be printed as it is on the screen. Also, I want to take the input of sigma y from the user. So sigma x, sigma y, and tau, three inputs. If I'm having, I can calculate both these values. So now sy is the variable where I'm storing this. Again, same thing I have to do. So I'll copy and paste for y direction. So this I'll be writing float input, enter the stress in y direction, and this will be sy. And for tau, I'm taking the variable. For tau, I'm taking the variable as t. And here also, float input, enter the value of shear stress. Enter the value of shear stress. So these three input user will be giving me, and then I will be calculating the values of principal stresses. If this can be done in the same way, you can write the formula separately, or you can write the formula in the print statement as we have done for the temperature calculation. So here I am writing the formula separately so that readability is there. So for finding sigma max, S max, I will be writing the formula by using the operators in Python. So here you can see the formula. Sigma max is Sx plus Sy by 2. So here inside parentheses, Sx plus Sy, the whole divided by 2. So this is the first part, and since it is S max plus, now the square root 1 and 2 right here. So again, it will be Sx minus Sy. Again, I'm using one more bracket. Sx minus Sy divided by 2, and this whole raised to 2. So for power In Python, raised to is double asterisk next to it. So this much part I have typed. Okay. And plus sign, plus operator, then tau. So the variable tau is my t here, variable t, tau का square. So again power, so double asterisk raised to 2. Okay, so the whole thing is done. The square bracket is remaining. So for square bracket, I will include this in one more parenthesis, and here again power raised to 0.5, square root is 0.5. So this is the complete formula for Smax. Similarly, so what this formula will do, once the user has entered the Sx, Sy and T ka value, so it will take all the values and calculate and then store the value in Smax. So we have to call the print statement. Inside the output statement, we have to call this variable with a f string or without a string, and we can get the value. So copying this same thing for S minimum with a minus sign. So on the new line number you can keep on by going in view, show line, or shift LED. So line number will be visible. So next line now I'm writing for sigma minimum, S minimum. The same thing I will be just editing here with the same formula with the minus sign. So S minimum is an operator minus sign will go in here so to get S minimum. And finally tau is this last one of the square root. So if this also we can copy from here. Already we have typed. So copy from here and T max. Okay, tau max we have to find T max and this square root one. So what this will be doing, this will be storing this variable will be storing the value of maximum stress, this will be storing the value of minimum stress, and this will be storing the maximum shear stress level. Now let us write print statement, output statement. So in this we can display stress, maximum principal stress is maximum principal stress, and here outside the quotes go and call the variable Smax. This will be printed. Similarly for minimum principal stress, I'll shift this up, and here this you have to change the label minimum principal stress and call the variable S minimum. And similarly shear stress, maximum shear stress, and call the variable T max. So all these values will be printed. So we are taking the input from the user, we are writing the formula, and then we are getting this printed. So let me execute and check, shift enter. So I'm putting a standard value 10 for sigma x, 10 for sigma y, and 10 for tau max. So if I run this, I'm getting, yes, maximum principal stress 20, minimum will be 0, 10 minus 10 it will be 0 the whole term, and shear stress will be 20. If you want to add unit now, so to make more aesthetically looking good, you can add unit megapascal inside the quotes. So this unit will be megapascal. So the same thing, all three has the same unit, megapascal. So that can be written megapascal. So on the output screen now you can see this units written in megapascal. If you want to round it, if you're using some, so you can go for round, or if you want to use modifier .2f as shown in the previous problem, you can use that also. So I hope how to insert the image inside the Jupyter notebook, and how to write the code to find maximum principal stress.